Hey guys, I just wanted to follow up with a few questions from the homework from the last class, the 8.4 homework. Specifically, the ones that people mentioned in the survey were number 8, 11, and 14. So I'm going to kind of talk about those. And if you have some specific questions over others that you can't get figured out, then definitely let me know and I can help you out with those as well. Okay, so let's start with number 8. Let's see, I'm going to make some space up here just so that I can kind of write it out. So on number 8, um, you're supposed to expand. Yeah, expand this. Okay, so I'm gonna kind of show all the steps just to kind of help you. So if it's a fraction, we know it's going to turn it into subtraction, right? It's going to be the top minus the bottom. So the first step, I would say, this is going to be log, let's see, what's my base? It looks like there's not a base written, so it's assumed to be base 10. So it's the log of the top, and the top is 10x square root of y minus the log of the bottom, which would be the log of 7z to the fifth. Okay, but I want to expand it as much as I possibly can. So when I look at just the first term, inside this logarithm, I actually have the product of three things. It's 10 times x times the square root of y. So just for that first logarithm, I'm going to separate that into addition of three logs. So it's going to be log of 10 plus log of x plus log of the square root of y. So that's just all from that first logarithm. Um, and then from the second logarithm, I'm going to bring that minus sign down. From the second logarithm, inside there we have a product of 7 times z to the fifth. But we're subtracting that entire logarithm. So I need to do this kind of thing, right, to show that that minus is subtracting the whole thing. So it's going to be log of 7, and because it's multiplication, this is going to be turned into addition here, and then it's log of z to the fifth. Okay, so I see a couple things now that I can do, right? I could apply that third log property, that because this is a square root of y, that's the same as saying y to the 1/2, right? So if I want, I could move that 1/2 down in front. So I've got log of, oops, I'm sorry, log, whoa, something happened there. Um, let's see, how can I move you over? Here we go. So it's going to be log of 10 plus, okay, sorry about that. But that's what it sounds like at my house when you're here all day, apparently. If anything walks by the front, the dogs have to bark at it. I'm not sure. I think maybe they saw a leaf move. Anyway, so I've got my log of 10 plus log of x, not changing anything there. I'm going to move that 1/2 down in front, so it's going to be plus 1/2 log of y. Now I'm going to distribute this minus, right, to both of these. So it's going to be minus log of 7 minus, and then on this one I'm going to move that 5 down in front. So it's going to be 5 log of z. So this is completely expanded as much as we possibly can for number 8. Okay, then let's look at number 11. This time we're trying to condense. So if I'm trying to condense, let's see, let me get rid of, whoops, let me get rid of this. So we have a little bit of space here. Okay, so I'm going to start combining logarithms. So how about I start with the first two right here? Well, because of the subtraction, I know I'm going to turn it into a fraction, but I can't do that until I move that 3 up. Okay, so how about I do that first? I'll move that 3 up, and I'll go ahead and move that 2 up. So what I have is log base 5 of 2 minus log base 5 of x cubed minus log base b of 3 squared, and I'm going to go ahead and say 3 squared is 9. Now, several of you noticed a mistake that I had on the last key. on the homework key, and that is I see here that the first two are log base 5 and the last one is log base b. Well, it's okay to have different bases in the same problem, but I can't use the properties on them if they're different bases. So in other words, what I'm saying is these first two, yes, I can combine those because those are both base 5. So for that part, I'm going to say log base 5 of 2 over x cubed. And then separately, I have this term, this minus log base b of 9. But that's all I can do. I can't combine this any further because the first one is a base 5 and the second one is base b. So I can't, say, hey, that's a subtraction and I'll go ahead and combine those. That's all I can do is just leave it just like that. So that was a really good catch, and several of you noticed that. So I was very proud of you. Okay, on number 14, that was another one that several people had asked about. Um, let's see if I can do this. How about if I move this up out of the way? Boom. There, that one's up out of the way. And let's clear some space here then for number 14. Okay, for number 14, first of all, that 1/3 applies to all three of the terms, right? So I'm going to think of it as 1/3 times 2 would be 2/3 log base b of m. Whoops, sorry about that. Here we go. 2/3 log base b of m minus, I'm going to distribute the 1/3 to the log base b of n, log base b of n, and then I have a minus 1/3 log base b of p, log base b of p. Now this is one way. It's not the only way to do it. This is one way to do it. Several of you had asked me about this method, so I'm going to talk through this one. They're all base b, so yes, I can combine them all. But before I can combine them, remember I have to move these numbers out in front, right? Move these numbers out in front, move these numbers out in front. So I could say that this one is going to be log base b of m to the 2/3 minus log base b of n to the 1/3 minus log base b of p to the 1/3. Alright, and now I can use that second property. I can combine these two, right, because of the subtraction. So I'm going to say log base b of m to the 2/3 over n to the 1/3. And then I still have this minus log base b of p, right? So it's going to be this minus log base b of p to the 1/3. So now I can apply that second property, right? It's subtraction. So it's going to become log base b of this first term, m to the 2/3 over n to the 1/3, m to the 2/3 over n to the 1/3. And if I'm subtracting p to the 1/3, it's like I'm dividing that whole thing by p to the 1/3, right? But I don't want to leave a fraction within a fraction. So instead of saying that I'm dividing by p to the 1/3, well, when you divide, don't you multiply by the reciprocal? So really it's going to be kind of like saying times 1 over p to the 3rd. And if I'm multiplying, then can't I just think of this as just one big giant fraction? So like it's m to the 2/3 over the n to the 1/3 times p to the 1/3. Now some of you were saying, hey, but that's not what you had for your answer. Well, yeah, it kind of is, because if they all have a 1/3, can't I think of that as log base b of this whole thing to the 1/3, right? Well, what is it that has a 1/3? Well, on top it's an m squared that has a 1/3. On the bottom it's an n and a p that has a 1/3. And so if you want to, I'm not saying you have to, but if you want to, that 1/3 you could think of as a cube root. So if you want, you could write this as log base b. Let me Let's kind of make this a little bit smaller here. Sorry about that. You could make it log base b of the cube root of m squared over np. So there's several different ways you could write it, and it's fine if you want to write it like this. It's fine if you want to write it like this. It's fine if you want to leave it like this. All of those I have simplified into one logarithm. Again, I'm not saying that's the only way to do this problem. I'm just saying it's one possible way to do this problem. One other thing that I would point out is some of you did not distribute that 1/3. And for most of you, that's like your first instinct to do that. But if you did not distribute that 1/3 and you just worked inside the parentheses over here, let's see, let me kind of make all of this kind of small, and I'll talk to you about those of you guys who did that, because it really does make it look a lot easier. I'm going to squeeze that way up there. So on this one, let's say you ignored the 1/3 and you just worked on the inside of this parenthesis, right? So you have like a 1/3, and then on the inside, this is going to be log base b of m squared, right? Minus log, log base b of n minus log base b of p. And then you said, okay, well now I'll just combine all the ones on the inside. So 1/3, and then on the inside I have log base b of m squared, and that minus means this is going to be over n, and then that minus again means, hey, this is going to go in the denominator, right, like a fraction, so it's also going to be over p. And isn't this the same as what we have right here, right? Because if you want to, you can move that 1/3 up as an exponent. So again, different ways to think about it. All right, so those were a couple questions that I had from the homework. So now what you're going to want to do is if you can, if you have a printer, you're going to want to print off the 8.1 to 8.4 review. I've got it posted there in the module, and then you have that there in front of you as you go through the next video, because the next video is going to lead you through a whole bunch of those examples from the review. So basically, I'm doing the review with you, right? And this is your homework. So I'm doing the homework with you. I'll take you through a whole bunch of them. The video is interactive, so there's going to be several places where the video will stop and force you to answer a question before the video will keep going. But make sure you complete the whole video. It's going to help you with the review. I'll see all of the results that you put up there, and it's not like I'm trying to grade them and count off if you get them wrong. I just want to see how you're doing so I can know maybe how to reach out to individuals and help you with some things before you take that big quiz, which is coming up on Friday. Again, you guys, I hope you realize I'm not trying to create busy work for you. In fact, I'm kind of putting in a ton of extra work so that I can really help guide you without me there, so I can kind of help guide you and really do well on this last big quiz, since it's the last one of this quarter. All right, be sure and let me know if you have any questions.